Okay, guys. So today we are going to start with the next part of the NMR. So yesterday you know that we did the chemical shift or the environments in a molecule. Okay. So today we are going to start with the next part. I told you NMR that is connected with the mass spectrometry. So today we are going to discuss a little bit about the mass spectrometry. Okay. Because mass spectrometry and the second thing, NMR, they are connected with each other. Okay, so let's start with the mass spectrometry, and after doing the mass spectrometry, we will do the NMR spectrometer. Okay, as a combined whatever we have studied yet. Okay, so let's start with the mass spectrometry. Mass spectrometry, my dear, it is a technique which is used to find out the AR or MR of a substance. The first thing. The second thing, mass spectrometry, it is used to find out the isotopic masses and their abundances. The third thing, it is used to find out the percentage composition or percentage by mass. The next thing, mass spectrometry, my dear, it is used to find out the empirical and the molecular formula of a compound. Okay, so let's start with the mass spectrometry. So, mass spectrometry is used to find out the three things. The first thing, my dear, it is used to find out the AR or MR of a substance. Okay. The second thing, it is used to find out the isotopic mass and their abundances. Okay. The third thing, it is used to find out the percentage by mass, or this is also called as the percentage composition. Okay. The fourth thing, it is used to calculate the empirical formula and the molecular formula. Okay, of a compound. So mass spectrometry, with the help of the mass spectrometry, we can find out all these things. So basically, we are going to concern with the empirical formula and molecular formula. And the second thing, the AR and MR of substance. So these two things, they could be used in the NMR spectrometry question. Okay. So NMR spectrometry and mass spectrometry as a combined, he's going to give you the question. So that's why I have joined the NMR and mass spectrometer all together. So we did the NMR spectrometer first part, the hydrogen NMR, and then we did the chemical shift yesterday. Okay. So now how does the mass spectrometer, my dear, it is going to work? So we are going to start with the working of mass spectrometer. Working of mass spectrometer. So basically a mass spectrometer, my dear, it consists of the three parts. Okay. The first part of the mass spectrometer, that is called as the ionization chamber. Okay. The second part of the mass spectrometry, that is called as the accelerating chamber. And the third part of the mass spectrometer, that is the magnetic chamber. And with the magnetic chamber, you got the detector with the recorder. So this is the recorder. Okay. Now the ionization chamber is attached to the heater like that. Heater and the ionization chamber has got a very fine nozzle. Nozzle is a hole through which the things could enter the other compartment, but they are unable to go back. Okay, so that is called as a nozzle. In the ionization chamber, we got the electron gun. So this is the electron gun up here, like that. Okay, so this is the electron gun. Okay. What is the electron gun and how does it work? Electron gun consists of a very thin wire and very lengthy wire. So that is why we have called it. You know that in the physics, if you study that very thin and lengthy wire has got the high resistance. So due to high resistance, it becomes hot. Okay. And you know that metal has got the C of delocalized electron. So when it becomes hot, so it will start giving out the electron. Okay. Like that. So electron would start coming out from the surface of the metal when it becomes hot. So that is called as the electron gun. Okay. Now, how does this whole spectrometer work, mass spectrometer? First of all, if you want to analyze the empirical or molecular formula or the AR or MR of a substance, what should you do? You should enter a small sample. This is the small sample into the heater. So this is the heater. So what does the heater do? Heater is going to heat it too much that if that thing is a solid, it would change into liquid and liquid would change into gas, vapors. So those vapors, they are sent into the ionization chamber. Okay. Let's suppose I'm going to suppose that these vapors, let's suppose if these vapors, they are of the water molecule. So I'm going to draw the structure of the water molecule up there. Okay. So these are the free electrons of oxygen. So now, when you enter the water into the heater, so heater would change it into vapors. So vapors would enter into the ionization chamber. So not only one water vapor would enter, millions or billions of the water vapors, they are present in one drop of water. So here millions or billions of water molecules are present. So with some water molecule, what would happen? The electrons of the electron gun, what they do? They got the negative charge, and these electrons, they also got the negative charge. So the electron gun electron and these paired electron, they would repel each other. So they will take these electrons, okay, outside. So this bond would break down, okay. So you will get OH positive and H positive. Okay. So with some water molecule, what would happen? The electron gun electron would come and repel one of the electron from the unpaired electron. So whole of the water molecule that would become positive charge as well. H2O positive. Okay, and with some water molecule, what would happen? This electron repels these shared pair as well. So the O that would also become positive, hydrogen positive we have formed. So whole of the molecule that would become positive, and that molecule will break down into the smaller pieces, and they would also get the positive charge. Okay, let me give you one more example. Let's suppose if this is methanol, CH3OH. Okay, so this is the methanol. So how could it form the positive ion in the ionization chamber? So this whole molecule that would become positively charged, CH3OH positive. So this bond would break. So CH3O positive and H positive. So this bond could break. So you will get CH3 positive and OH positive. Okay. So in this way, the whole molecule and its fragments, they would form the positive ion in the ionization chamber. So in the ionization chamber, you got a large number of the positive ions like that. So positive ions are formed within the ionization chamber. Everyone got it, guys? Everyone?
Yes, sir.
Okay. Now what would happen, guys? We got a plate up here. So this plate is actually negatively charged plate. Negatively charged plate. This is negatively charged and it has got the holes inside it. So what does this plate do? This plate is going to attract these positive ions towards itself. Okay. So when these ions they are attracted towards the negatively charged plate, so their speed would increase. And you know that whenever there is an increase in speed or velocity, that is called as the acceleration. So this is called as the accelerating change. Okay, so these positive ions they are attracted towards this negatively charged plate. So when they come close together to the positively charged plate, their speed, some of the positive ions they got too much speed that they would pass through these holes and enter into the magnetic chamber. Okay, like that. Whereas some of the positive ions which got the low speed, they would be attracted towards this negatively charged plate. Okay, so in this way, some of the positive ion they would attach with this negatively charged plate, and some of the positive ion they pass through this negatively charged plate and enter into the magnetic chamber. Okay, now my dear, this magnetic chamber it got the magnet. Okay, whose direction is out of the page. This is out of the page, and if you got a cross like that, so this shows into page. So out of the page means that the direction of magnetic field is outward. So positive ions are moving in that direction. Magnetic field is outward. So the Fleming's left-hand rule is applied up here, which would attract or repel these positive ions. So this is the Fleming's left-hand rule, guys. This thing shows the current. Current is basically, you know, that conventional current positively charged. Okay, this is the magnetic field and this is the force applied on the positive ions. So direction of the current is this one because positive ions are flowing in that direction. So up here, magnetic field is outward. So outward, so the force is applied downward. So these positive ions, my dear, they would be deflected downward. Okay, they would be deflected downward. So when they collide with the detector, detector sends the signals to the recorder, and recorder is going to record these values on a graph paper in which the y-axis it shows the abundance, whereas the x-axis it shows the m over e value. M over E value, and in some books it is written as M over Z value. So M word shows for mass and Z or E shows for the charge. You know that all the particles mostly they got the plus one charge. Okay, so plus one, that if it is divided with the mass, you will get the mass. So this m over e value actually shows the mass. Okay, so let's suppose if this positive ion strike on the detector one time, so a peak would appear like that. So this, if any positive ion strike at that point again, so this peak would become little bit bigger, again bigger, again bigger, again bigger. Okay, so the time to which the positive ion strike that point, the peak would appear, and that peak would become slowly upward, bigger, bigger. Okay, so up here another peak is formed, which would become bigger. That how much time the positive ion strike on that point. So in this way, my dear students, you get the different types of the peaks. Okay. Now we are going to study all these peaks up here. Okay. Okay, my dear students. Now we are going to start with the different peaks formed. Okay. This is the abundance. Okay. So this is the m over e value. So the different peaks they are formed like that. Okay. So if these peaks they are present at a distance of 1 or 2, let's suppose if these peaks are present at a distance of 1 or 2, so basically these peaks are actually the isotopic peaks. Okay, so these are the isotopic peaks, and their abundance is given along the y-axis. Sometimes this abundance is percentage abundance, and sometimes it's in the form of number. So it could be in any case. So by using their masses of the isotope, we can find out the average AR of the isotope. So average AR of the isotope could be calculated, my dear, how? By taking this mass number 21 and how much abundance it got 2. So times 2. And just like that, 22, how much abundance it got? It's 5. And then 23 times 3. And then 24 times 1. Now, what should you do? Don't take this total abundance as 6. You should add these abundances 2 and 5, 7, and 3, 10, and 1, 11. 11. So, if you just divide this whole thing, you will get an answer which is the average of these isotopes. So, this is the simplest thing. You people have studied it in your A1 as well, but this is the part of up here. Mass spectrometry is actually included in the A1 as well. Okay, but it is also the part of A2 in the with the NMR spectrometer. So you should know the basics. So that's why some of the students, if they have taken my A1 classes, I have done the same thing up there. Okay, but this is the part of A2 as well. Okay, guys. Now we got the different peaks up here. Okay. Let's suppose this is present at 18, this is present at 39, this is present at 63, this is present at 91, and this is 92. Now, these are the m over e values again. So if you look along the x-axis, the peaks, they are present at an unusual, unequal distance. Okay, so if the peaks are randomly present, so these peaks are actually the compound peaks. They are not isotopic peaks this time. They are the peaks of some compound. Okay, so when you got the compound peaks, you mainly have to focus at the end peaks, at the end peaks which are very close together. So the two end peaks, they are very close together. Okay, so these two peaks. So one of them, the first one, that is called as the M peak, and the second one, it has got a distance of 1 up here. 91 plus 1 would become 92. So this one is M plus 1 peak. Okay, so when you people got M and M plus 1 peak, it means this one is formed due to carbon 12 and this one is formed due to carbon 13. Okay, carbon 12 has got the existence in the nature 98.9%, and this one has got the existence in the nature 1.1%. Using this abundance of the carbon 13, we can find out the number of carbons from a compound. Okay, how? M plus 1 into 100 divided by m into 1.1. So this m plus 1, that should be the abundance value. What is the value of abundance of this m plus 1 up here? This value you should take. Don't take this value 92 up here. Okay, the m, that is also the abundance along the y-axis. So put the value of the abundances of m and m plus 1 in that formula, and by that you can find out the number of carbons in a compound. Did you get it, guys?